Two clocks, identical, synchronized to the same second. By the end of this experiment, they disagreed by almost 300 nanoseconds. That's not a malfunction. That's not a rounding error. That's time actually, measurably, physically moving at different speeds. In October 1971, two physicists named Joseph Hafele and Richard Keating did something that sounds almost absurd. They bought plane tickets. They packed 4 cesium atomic clocks, the most precise timekeepers on Earth at the time, into carry-on bags, and they flew around the world twice. Once eastward, once westward. They weren't on a research vessel. They weren't in a lab. They were in coach class on commercial flights, eating airline food, watching the clocks tick. The experiment cost about $8,000, cheap by physics standards. But what they confirmed, what those clocks revealed when the planes landed, changed the way we understand something as fundamental as time itself. Because here's the thing most people never learn in school. Time is not a constant. It doesn't flow at the same rate everywhere. And Einstein didn't just theorize that. He calculated exactly how much it would differ decades before anyone could test it. So when Hafele and Keating finally compared their clocks to the ones left behind on the ground, they were checking Einstein's math. Einstein's theory of relativity makes two predictions about time that feel deeply counterintuitive. First, the faster you move through space, the slower you move through time. Not metaphorically, physically. A clock on a moving plane ticks slightly slower than one sitting still on the ground. Second, gravity warps time too. A clock higher up, further from Earth's center of mass, ticks slightly faster than one lower down. The same way a river runs differently depending on its slope. These two effects pull in opposite directions on an airplane. The speed of the aircraft slows the clock down, but the altitude speeds it up. The net result depends on which flight path you're on and which direction you're flying relative to Earth's rotation. Hafele and Keating knew this. They calculated what the clocks should read before they ever boarded a plane. That prediction, those exact nanosecond values, was the real experiment. The flight was just the proof. What's remarkable isn't that the clocks disagreed, it's how precisely they disagreed. The eastward journey slowed time, as predicted. The westward journey advanced it, also predicted. The numbers matched Einstein's equations within experimental margin. This wasn't a simulation, this wasn't a thought experiment. Time literally passed at a different rate for those clocks than for the ones left sitting in Washington. And here's where it stops being abstract. Modern GPS satellites experience both effects every day. Their onboard clocks run fast by about 38 microseconds per day relative to clocks on the ground. A tiny but compounding difference. If engineers didn't correct for it, GPS navigation would drift by several kilometers within hours. Your Maps app would send you into a field. We're not just observing time dilation, we're engineering around it. So what exactly did Hafele and Keating prove? Not that you can travel to the future in any dramatic, cinematic sense. The differences are tiny. You'd need to move at a significant fraction of the speed of light or spend years near an intense gravitational field to experience anything perceptible. But the principle is real, confirmed, peer-reviewed and replicated dozens of times since. Time is not a backdrop. It's a physical variable. It responds to speed. It responds to gravity. And every clock, including the biological one running inside you, is subject to these effects. The astronauts aboard the International Space Station age very slightly slower than people on the ground. Not enough to notice, but enough to measure.
What Hafele and Keating did in 1971 with carry-on luggage and airline tickets was give physics something it rarely gets: a clean, unglamorous, undeniable confirmation. Einstein was right. Time moves differently depending on where you are and how fast you're going. We've been living inside that fact ever since, navigating by it, engineering around it, mostly without noticing it. If an $8,000 plane ticket could confirm a fundamental truth about the universe, what else are we missing sitting just beneath the surface of ordinary life? The next video explores an equally strange corner of physics that most people never hear about.